So good afternoon, everyone, and thank you for coming to this seminar at an exceptional time. So it's not yet the last seminar of the year. There will still be a seminar next week and on our usual time on Friday. So for people online, hopefully you hear me. And so if you encounter any trouble during the seminar, just put your comments in the chat, and also put your question in the Q&A table so we can get you to ask your questions at the end of the talk. And I think there was also an extension of the submission for the seminars next year. So it's the 13th of June, so don't hesitate to invite people, and that's for everybody. That's for researchers, but also for postdocs and PhD and everyone. So don't hesitate to invite who you would like to have coming at the seminar. And with that, I will let Emmanuel introduce today's speakers.
Bonjour à tous. Donc, je suis le chef de culture du jardin et plantes de Montpellier, et le jardin fait partie de l'association française des jardins botaniques et de l'association internationale. Et en fait, Peter, qui est conservateur du jardin botanique de Melbourne, c'est le collègue de la francophone. Il me dit, bah, tiens, il y a le collègue australien qui vient en France, il voudrait aller dans quelques jardins botaniques, donc on a la chance de l'avoir parmi nous. Alors, il fait partie de l'Alliance du changement climatique dans les jardins botaniques, et c'est une des personnes qui, notamment à Kew Gardens, qui pilote ça, mais lui, sa spécialité, c'est vraiment de parler de la spécificité des jardins australiens. Voilà. Donc là, Peter va nous parler donc des kind of prevention and adaptation in the landscape and landscapeization with the focus on the Australian botanic gardens. Okay. Thank you very much.
Thank you. I know my accent is going to be difficult, so wave at your hand up if I'm speaking too quickly. Feel free to wave at me madly. Okay. So this is going to be a story about the experience of Melbourne Gardens and how it led to a landscape succession strategy and the Climate Change Alliance of Botanic Gardens. But I'm also going to give you some background in climate change. A lot of you will know this information well, but it might be a reminder for some, a bit of a refresher. I'm sorry if you already know you're all experts in this, but some people might not know, and I'll try to cover for everyone. So, now this thing's not going to behave. Oh, there we go. So, we like to respect the First Nations of Australia, but also around the world, Aboriginal people in our place, in our area. We don't do that just because we think it's the right thing to do. We also recognise that these people have lived on some lands for tens of thousands of years. So in Australia, 65,000 years, it's known. They have lived through climatic shift, change, and experienced all sorts of things. The way they see the world and the way they manage landscapes is actually arguably better than what we do as a white person in Australia. Their recollection of events tens of thousands of years ago has been found to be remarkably accurate when scientific researchers examine the same things. So the way that they can pass on information is something we need to learn when we have expertise, particularly in climate change. So I'd like to acknowledge them. I'm not going to actually show too much French-related information because you probably know all this. But this temperature trend here, and the point is not going to work, but anyway, that's all right. That trend is pretty similar for every city around the world. There's obviously a marked increase. Some of this would happen whether we had climate change or not. So we have urban heat. So buildings, roads absorb heat and re-emit it during the night. Had no climate change, you'd probably still see something like this, but it probably wouldn't be as high. So France is particularly concerning because the average warming is about 1.7 degrees, which is actually above the global average. So your country is warming at a higher rate than a lot of other places. So it adds to the challenge, if you like. So a way of thinking about this, some people struggle to understand why we suddenly get more extremes. Now, why do we get more hot days? Why do we get more droughts, if you like? So you can imagine, because this thing's not working for me. Imagine the shape on the left, that bell shape. That's the current conditions, the average conditions. When temperature shifts, that shape in a way moves. And so it's just not pointing. Because it's a monitor. Yeah. It's all right, we'll go without it.
Yeah.
So because that whole shape moves away, we get less cold weather. But then that shape moves into an area where things that were uncommon, such as really hot days, we get more hot weather, and we got more extreme hot weather. So I've experienced 2 episodes in Melbourne in my lifetime where we had 3 days above 40 degrees Celsius in a row, and then 4 days above 40 degrees, and I'm talking 42, 43 in a row. So you think it's hot here when you're struggling with 30 degrees or 33. Imagine if it was 43. Now, 20 years ago, we didn't seem to get that. So the extremes are happening more often. What about if we look at France particularly and look using a climate classification? So this climate classification is based on scientific observation of certain plant types or certain vegetation around the world that shared common climate characteristics. So it's a way of sort of visualising climates that are linked to certain vegetation or plant types. So this is the current climate, and your very general terms, you're within this temperate, warm. Well, not so much down here in Montpellier, sorry. I've made a mistake here. This is actually, ignore that. It's this one here. See, so more Mediterranean. Sorry. This presentation's been changed that many times. I've lost track where I am. So it's the yellow one. So you're sitting in that zone. But what happens with more extreme warming, more severe climate change? You can see there's a dramatic shift in climate types. So for a lot of France, it becomes a temperate climate that has a hot summer rather than a warm summer. Where the Montpellier garden is, it still sits within that Mediterranean climate zone. But this brown, I'm going to point, this brown one here, this is actually a desert climate zone. And you can see that is growing, it's growing northwards. So it's spreading close to where you are. So potentially becoming a lot more arid. Another way to look at it is to use what we call analogues, or places that are similar to your future. What cities or locations have the conditions of your future climate? So if we just look at 2 degrees Celsius for Montpellier, the cities or the areas that align with that, looking at mean annual temperature and using a parameter called climate water deficit. So the water that's, if you combine, take precipitation away from potential evapotranspiration, what is the amount that the plants need? And sort of trying to make it simple. We put those together, they're the cities that sort of match your future. Well, that's at 2 degrees C warming. Keep in mind that climate change has already occurred. So we keep thinking about seeing it as a future thing, but we've already had significant climate change. So you're probably halfway to those cities already. But 4 degrees really gets quite dramatic. So heading way down here, Tunis, you're heading right into the southern part of the Mediterranean. This does not mean that those climates exactly match yours. And if you use temperature and water, it gives you an idea of the magnitude of the change. So we're talking potentially, thousands of kilometres away. What about plants themselves? What does this mean? So the image on the left refers to a tree called Araucaria angustifolia, growing in the mountains of Brazil. And with under more severe climate projections, its range is expected to contract by 65 to 80%. The unfortunate thing for that tree is where it is projected to be able to grow, it moves from protected areas into private land or areas that landowners can chop down trees. So not only has its growing space shrunk, it's shrunk to an area where it's even more vulnerable by people chopping them down. So for that poor old tree, there's a risk. So the other thing I wanted to mention is with 1.5 degrees of warming, about 8% of plants lose about half of their climatically defined range. So think of their growing space, their climate growing space shrinks to half. We only go to 2 degrees and that 8% becomes 16%. We go to 3 degrees, it's estimated to be about 44%. So you can see 3 or 4 degrees really starts to constrain where we think plants can theoretically grow. Problem in Australia, that picture on the right is our beautiful snow gums. So in Australia, we have gum trees that grow in the snow, and they typically grow above 1,300 metres. So Australia is you've got the French Alps, you've got real mountains. We have little mountains. So Australia's average elevation is 300 metres. It's the lowest continent on Earth, basically. That picture of snow gums there, that's 1,700 metres, and that's getting close to the top of our mountains. So our highest mountains, can't remember, but it's 2,200, 2,300 metres. That's our highest mountain in Australia. These snow gums are growing on the top of a mountain ridge. So if they need to move upwards, and research is showing plants are shifting ranges all over the world, this is not new. Some of you will know this. Where do they go? They can't get a helicopter and find a spot up here. So they're constrained by that elevation. Plants are constrained by coastlines, by mountain ranges, by artificial things like bridges and roads. So they have all these barriers on the way. The thing with snow gums is it's not as simple as it sounds, because it's not just temperature rise. We also get more frequent fires. And those fires preference other types of vegetation. So grasses and shrubs can now compete with snow gums as well. So not always as simple as we think. The other problem is, from Australian context, that plants aren't like us. They do move, plants all move, but they move in timescales very different to ours. Hundreds of thousands, they need hundreds to thousands of years in some cases. So for eucalypts, it's been estimated their capacity to move is maybe up to 2 metres a year. That's as far as they can disperse their seed. So trees here, it's moved to here. If I need to move 800 kilometres, which is the projections for some, in 50 to 100 years, I can move 50 to 100 metres, maybe 200 metres. Can't move quickly enough to keep up the rate of temperature. And that's a particular characteristic of our eucalypts. This is a Victorian high country, montane country. It's had a fire, you can see the dead trees. What about rare plants that are also vulnerable because they're rare? They need a certain velocity to move, but their capacity to disperse seed is not very good. All those red dots are all plants that are considered to not be able to spread their seed, but also they need to move a lot faster. So there's some of the issues. So what's been observed around the world when it comes to what are we seeing in terms of plant response to climate change? One of the main things that's been observed is what we call hotter droughts. So drought, high temperature brought together, not a good combination. So global forest mortality has been observed all around the world, across climate zones, across countries. One study in Australia looked at 17 different forest types, different elevations, different climates, and there was die-offs across all those. That picture there is the Melbourne Gardens, and this was after 3 40-degree days. the Stewartia. I don't even know it. Stewartia pseudo-Camellia. It's in the Camellia family. It dropped dead, just died. This bed is actually irrigated. So you notice some plants are still okay. The plant in the front, I think it was an Escalonia. I can't quite remember. But those two trees just dropped dead. So what's the theory behind this? I'm going to try and give you a little bit of science, but not make it too heavy. There's two mechanisms. One is the plant's capacity to transmit water up the stem. So there's physical limits of how far water can be pulled up through photosynthesis. That's why we don't have 300-metre high trees. They just can't physically grow that tall. So some plants are risk takers. They don't regulate their water use. They just hope that it will rain in time. So they just keep using water. And what happens because of that severe pull on the water, you get air bubbles in their tissues or embolisms. We don't operate too well with blood, air bubbles in our bloodstream, and even do plants. So they can fail because the conditions are so severe. The other group of plants are more conservative. They keep their money in the bank. They don't spend it. So they regulate their stomata on their leaves, so the pores, their breathing pores, and they shut down photosynthesis every time conditions are severe. The issue with that is if they do it too often and for too long, they're not producing photosynthates or food from photosynthesis. They starve themselves to death. And conifers are a group that tend to do that. They tend to hunker down. And so this tree on the right, this is a picture of a tree in the Ballarat Botanic Gardens in Australia. It is a conifer, but I think I'm seeing hydrite failure in this tree. These trees were irrigated through the drought, had plenty of water, and yet they still got dieback and losses. So this is in a botanic garden, it's not in the natural forest. You can see how the top's dead, and the right-hand side is north. So in where I'm from, north faces the sun. It's in the right side of the sky in Australia, not like here. Died on the side and on the front. This tree is already being observed to be dwarfing because they can't physically, in some parts of Australia, they're seeing dwarfing of trees, but they can't physically move the water to the top. So there's some of the issues. So the cause of this is considered to be something called vapor pressure deficit. So in simple terms, that's the evaporative demand on plants. The issue with this is every time that the temperature goes up 1 degree, that vapor pressure deficit goes up much more steeply, more exponentially. So that's the theory behind why we're seeing this sort of thing. What about fires? And I said I wouldn't talk about France, but it seems like you've got similar issues here. We're very used to bushfire in Australia. I've seen many bushfires in my lifetime, killed people. So bushfires on their own in Australia, or even in the Mediterranean zones, are not a problem because the vegetation is adapted. But what happens if the fires are more frequent, more severe, and longer duration? And that's what we're seeing all around the world. You can see Australia's burnt areas, just to give you an idea how much Australia burns. That red zone up the right here, this area here, there's rainforest growing up here, and the fires have burnt into rainforest, which never normally burn. So we're losing rainforest plants. An area that I love going to, beautiful mountain stream with a waterfall. There's a tree called Nopophagus cunninghamii, Antarctic Beach. Like this, like Lord of the Rings type trees, beautiful mossy. Some of them are dated to be 800 years old. Last lot of fires killed these trees outright, completely dead. So for me, I'm thinking that's a 1 in 800 year event we're now seeing. These trees are growing in a rocky waterfall, hardly any plants around, just the sheer heat from the fire killed them. And there's evidence of this around the world. But you also have the same challenges in France. Your projections for increased fire risk, particularly where you are here, in this region, is increasing. And, I've been talking to people around France, and this seems to be a bit of an emerging theme for you. You're getting new pests arriving that suit to the conditions, but also existing pests can become worse. So that picture on the left, this picture here, myrtle rust, arrived in Australia, I think it was 2012, haven't got the right year quite right, might be 2010. We had plants of the Myrtaceae or the Eucalypt family that were common, are now critically endangered because myrtle rust has just smashed them to death. But diseases that you already have can become a lot more severe. So this disease on the right, Botrytis, type of branch canker, normally just kills a bit of the branch at the end of your tree. It's now killing whole plants because the plant is under stress. This disease is able to say, yep, I'm going to have the whole lot now, not just a little bit at the end. So these are the challenges. And this is the last, more technical stuff. Some of the things we don't know about is how is it going to affect mycorrhiza. So mycorrhiza are fungi that support plants. They're symbiotic. So orchids, pines, whole range of plants have these relationships. What we don't know is if a certain pine needs to range shift, like move, can the fungi also go with it, or is the conditions not suited to the... So the fungi and the plants can't go together, those plants become more susceptible. And orchids seem to be a particular group we're concerned about. We don't know at the moment, but it is something to think about. The other one I wanted to mention is just water repellency. The soils get a hot day and the soils are dry. They can trip into water repellency. This picture here, this is taken in Melbourne Gardens. Their fingers of water wetting unevenly. This is all bone dry. And this was like 25 mils of irrigation. It's done, hasn't wet at the top where the organic matter is. So if you're trying to maintain shrubs, soil's not wet enough, they're under more risk. Do a quick time check. The other one I think's a challenge, and I'm probably giving you doom and gloom here, but we've got some hope, so don't all get depressed. Is invasive plants. So this is a tricky one because if we're selecting plants for the future conditions and they're suited to those conditions, they may also become terrific weeds. So we've got this tension between trying to grow plants for our botanic gardens that are suitable, same time not introducing invasive species that are going to cause a headache. I don't have an answer, but we need to assess the risk of climate change. We also need to assess the risk of invasiveness. We don't want to introduce a new horrible weed into our garden or into our natural areas. So moving more into what happened at Melbourne. Melbourne Gardens has had quite a strong history of really good baseline information, measuring water use, soil moisture sensing, lake water management, whole range of studies working with other universities. So it's a really strong scientific foundation that we had before we even started to look at climate change. This is an example of one study. We did our own internal measurements. We also had a Monash University PhD candidate looking at microclimates across the gardens. The question we had is, can we manage the landscape to mitigate climate? Now, do we need to do anything? Because can we just move plants around the landscape and keep them happy? So we monitored 19 sites overall across the site. We compared it to the city's weather station, and we also have a weather station on site at Melbourne Gardens. Compared the temperature. And we only really looked at really warm days. So I looked at days of over 30 degrees Celsius. So between sites on really hot days, there's about a 1.4 degrees Celsius difference. Irrigation, if we're irrigating it, we tend to provide about a 1.7 degrees Celsius cooling effect. In Melbourne, 1 degree of cooling actually saves lives during a heat wave. So just think about that. And on certain hot days, these two sites here, the Oak Lawn and the Fern Gully, were up to 4 to 6 degrees cooler. You think, well, that's good. There's some pretty significant differences there. But if I average that all out across all the sites, we're looking at about 0.5 degree difference. So the message is you can use microclimates to mitigate extremes. Plants that are in the sun, you move into more shade, keep them out of the wind. But it's not going to be the answer for all you haven't got the room to grow all your plants in all these spots. So I would argue microclimate isn't the answer. So what do we do? Sorry about the text being hidden there. It was fine on the computer. So we looked at a landscape succession strategy. And at the time we thought, surely, this was about 2013, 2014 when we started, surely someone around the world has done this work. So we did a worldwide literature review. I also posted information on LinkedIn, so social media, Botanic Gardens professionals, 5,000 members. Didn't get any response. Okay, let's go a bit wider. What about horticultural LinkedIn group? That's 50,000 members. I didn't get one reply that was saying, yeah, we've done that. So I'm sure someone would have liked to boast about it. So we realised that we're on our own. So what were we looking to do? We wanted to maintain the character of Melbourne Gardens landscape here. You can see how beautiful it actually is. We had to maintain that character, but adapt it to the conditions of 2090. We also realised we need to do something now, because every time we plant a tree or any shrub, that might be there in conditions of the future. So we have to make better decisions. We also had to protect the recreational, the scientific, and the educational values of this garden. Heritage is a funny term that gets used in gardens. It's often used as a way of blocking progress. Oh, you're going to damage the heritage. But for botanic gardens, science is actually part of it. That's what makes them heritage. It's the science. Without the science, you're not a botanic garden. Sorry, no science, you can't call yourself a botanic garden. So doing research and science is part of what makes the garden, gives the garden its heritage. I think I've said all I want to say about that. So what does this mean? These are some of the values that came out of preparing this plan. And I'm not going to talk about all of these. Some of these are obvious. Collaboration, working with other people. Human well-being is an interesting one. You may not know this, but some of the studies looking at plant diversity found that the higher the plant diversity, greater mental health, well-being benefits for human beings. And botanic gardens are high in plant diversity. That's what makes them special. So what it means, if someone comes in the botanic garden, has a bit of stress, they're going to get more benefit from a botanic garden than a typical park. But you may not also know that green spaces and gardens are really good for our thinking, our cognition, our memory. And studies with school children found when they were exposed to more diverse spaces, when they went back to school, they got better results in maths and science in their tests, just by walking through the garden and going back to school. Nothing special. So I think botanic gardens have even like they're supercharged with stuff with humans. Not the only reason we have a botanic garden. Funding is another one. We had a donor give us money to review a hydraulic model for an irrigation system. This is something under the ground. There's no lovely thing for the donor to put their name on. But because of this plan, because it was visionary, people were wanting to be part of it. And so we had money flowing in for projects that we could never get before. I think I'll keep it there. So we realised we had to do a more sophisticated climate risk assessment of the landscape. We knew there was risks there. I'd done some work and I worked out about 35% risk, which was a little bit, it seemed to be a bit amplified. So we looked at the risk of plants from mean annual temperature change. And that's found to be quite a robust predictor of plant distribution. So this is the current climate. Each of those grid squares is 100 square metres and it's an average risk for all plants. So it's all the plants growing in that grid, trees, shrubs, perennials. So under current climate, it's not too bad. There's some areas sort of lighting up a bit orange and a bit yellow, which means they're starting to get on the edge of their temperature. But remember, Melbourne had already warmed up a lot of it from urban heat by about 2 degrees, so we're already had climate change. But when we get to a more extreme scenario, you know, and that's where we're still heading as human beings, we're still heading into that extreme scenario, you can see areas becoming quite severe. Really orange and red down here. Everyone's looking a bit sleepy. Am I boring you? No? Not bored? Good. Wake up. This teasing. That area down there is the New Zealand collection. Who knows New Zealand? You can understand. No, New Zealand, cool place. Good. So that's under risk, and understandably, because New Zealand's temperatures are like 10, 11, 12 degrees, and Melbourne's 16. But does that mean that we get the chainsaws out, get rid of New Zealand? No, we changed what's a heritage collection? We said, well, being in a warmer climate, we can observe these plants in the gardens and we can talk to our colleagues in New Zealand and say, look, this plant here is really struggling under heat. If it's struggling in cultivation and being looked after and it's struggling, how much more so is it going to struggle in a natural environment? So we can act as a forecaster, a living forecaster for another garden. You can do the same thing here for another garden. Do exactly the same thing. Whereas this collection here, California, we decided that we would start to collect plants from warmer climates, and we broadened this out and made it the American drying, so we could collect plants from Arizona and more southerly, because we decided that was a better thing to do with that collection. The good thing about mapping like this is it really spatially shows you where your vulnerabilities are and where you need to manage, and you can start to make some decisions. Decision support, not decision making. It's not about we've got to do this, it's well, let's think about it. And this sort of thing is actually embedded in the horticulturalists and melt. It's actually part of their practice. When they're selecting plants, they have to look at climate and build that in. I want to show you the climate assessment tool. This was a project from the Climate Change Alliance of Botanic Gardens. I was the project manager for this, but not the scientist. I'm not a scientist, but I worked with a doctor and Botanic Gardens Conservation International and a few other agencies. And we developed this tool that actually picks up the climate risk for most of the world's trees. This is free. You can go and start using this right now. Probably not have known about it. And I picked on a plant for Emmanuel, one of his most loved plants in the gardens, and said, what about the Filaria latifolia? How does it stack up? You might have to use latitude and longitude. If you don't know, you can actually put that in. If you go to this site, it's pretty self-explanatory. So under current climate, this is what it looks like, Filaria latifolia. There's a database missing here, which is urban trees. So we actually have a database for plants from 500 cities, which shows potentially how much further they can tolerate temperature. So it's in the green, which means it's the top of that bell curve. It's in its comfort zone. And then we go to the intermediate climate and it starts to drop away, but still, probably still okay. And we get into more extreme climate. And one here, it's at the edge of the known temperature for this species. So based on the data of where the species occurs, we don't know a lot of species growing at that temperature. Does not mean this tree will die. Remember, this is decision support, it's not decision making. You still have choices. But it does say you need to really start to closely watch this tree. If your whole garden is planted with these trees, I would be starting to replace some of the more suitable trees. There's just too much risk that they could all fail. But for one really heritage tree, you might do as Emmanuel's been doing, put mulch around it, protecting it, trying to support it. It could be zero and it could still survive. But when you hit a zero, we have no knowledge or no record of that plant at that temperature. And plants tend to be constrained to their temperature. Another tool you can use is using GIS with spatial layers, and you can get data that's linked to certain bioclimatic parameters or environmental layers, if you like, for plants. So I've just done a very simple one. I'm a horticulturalist, by the way. I'm not a particularly whiz, but I can do this. Use QGIS. And I looked at the range of 17 to 19, which is the projected range for Montpellier. Very similar to Melbourne, actually, the top one. So I said, okay, what areas of the world match that temperature? Yeah, that's good. But I also don't want to look at water because I have to irrigate. You know, what's going to be the irrigation stress on the plants in the future? So I want to look at that as well. And then I say, well, let's put those together because we've got to think about temperature, we've got to think about irrigation. What does that look like? And that then pulls out areas in the world that could match your projected conditions here. Not an exact science, but it gives you a bit of an idea. Word of warning here, if you try to make this really exact and you build in a lot more parameters, you will find there's nowhere in the world matches your future climate. You won't be able to find anything because climates are quite complex. So you've sort of got to get that line between precision and productivity. And temperature and rainfall are good ones to work with. You know, you've got areas here in Australia. And this is a similar pattern for other French gardens, but yours is the most extreme that I've seen. This is a tool that anyone, if I can do it, Anyone can do it. So what's the Climate Change Alliance about? This was set up in 2018. It now has 500 members across 97 countries. We would really love to have many more French botanic gardens as members, because when we're thinking about climate change, we need to act locally, but the problem is global. And imagine if we can pull together all that collective intelligence of everybody from around the world, across country, culture, continent. You have expertise here that we don't have. We might have expertise that you don't have. Why don't we share it? And so the Alliance is about a knowledge sharing platform, really. But there's also some plants moving around. Oaks that are vulnerable to California come to Melbourne Gardens because it's currently cooler. And this was based on a living system model. So we based it on very landscaping the plants that we look after. We based it on living things. We wanted this to be an organisation that will continue to adapt and change. Hasn't been entirely successful, but that was the aim. But it's very active and working very well. Another thing that was produced is a landscape succession toolkit that is also freely available from that website. Admittedly, it's in English, but I'm already hitting some people up to help with a French translation. We recognise that we need to carry out more translations, Spanish, French, whatever major language there is. But we need people to help us with it. I can't speak French for the life of me, so I'm not going to be able to do it. But there's tools available. So if you need to develop an adaptation plan for your garden or your enterprise, there's some information out there that might give you some ideas of how to go about it. What's been happening around the world? It's the first one, and this plan here was developed with strong horticultural input. This was actually written by horticulturalists, not scientists. Scientists helped, but it was written by a team of horticulturists, and I was the lead author. That was followed by University of California, Davis, quite some time later, and then Kew did theirs, and everyone goes, "Oh wow, look at that, Kew's done one." But Australia was a little bit ahead. Kew have actually copied some of the text out of that toolkit, and they actually do acknowledge in their plan that they used Melbourne's work to inspire them. But I think if Kew does it, you'd start to think it's important if Kew does it. Yeah. So what's the theory about changing landscapes? What do we call it? So we use the word landscape succession. If you're an ecologist sitting in this room, you probably think I've done a really clunky job of this. Try to keep it simple. But plant systems go through a cycle, what's called succession. So they start off with mosses and lichens, break down the rock, nutrients available, other plants come in, and then eventually you have a mature vegetation type, or what we call climax vegetation. Most botanic gardens have this bit here. They're all up in this spot. Have you noticed that the plant diversity, the number of plants has dropped off, the diversity's become less, got a big mature overhead canopy. It's lovely and shady, it's great. But it doesn't allow for change or more diversity. So in natural systems, rainforest, tree falls down, opens up space, light, water, all these other plants then take off and fill the space. And we call that secondary succession, this one here. That secondary succession usually is more diverse, more plant species, but it'll progress back into mature. So how do we do this? How do we do this in the landscapes? The concept is we'll either take the opportunity of a tree falling down to replant it with a more suitable species, or we'll deliberately change areas, but do them in small mosaics, small patches, so we're not damaging the whole landscape. We're still keeping the big benefits of these brothers here, but we're doing it in a patch by patch. So the time we get to 2100, we've converted our landscape by stealth. No one knows what we've done. So here's an example that, I'll go back one, sorry. That area down the bottom there, Australian drylands, that was plants collected from Queensland, much warmer and drier. That was actually a project. Century Garden, which is plants for human well-being, also included warmer, drier plants. And then we had an oak tree, which is opportunistic because the tree fell apart. I'm going to talk more a bit about that. But this is our target here. We're looking at about 130, 200 new taxa across that 400 square metres a year. And so far, Melbourne Gardens has done about 18.5 years worth, so it's actually ahead of where it was aiming for. Don't know if that continue. We also need to do these bits. And these are the more challenging because sometimes you have to remove plants that appear healthy. People don't like doing that. If only doing small patches, it's not a great drama. So what does this look like? This is the Quercus of Finn alba, the white oak. Believed to be about 150 years. There's some of our soil moisture sensing and water catchment, scientific work happening at the gardens. That tree there just completely fell apart, just collapsed. Not particularly because of climate change, even though it's not suited to a future climate. But instead of chopping it all up and just planting one more tree, we said, why don't we use this as a learning exercise? We left the actual branches lying on the ground, planted 4 or 5 new oaks that are climate suited, and included some information for the public. So it became a learning space. So we used oaks from other botanic gardens because oak trees cannot be preserved typically. They need to be grown as living specimens for conservation. So we're actually helping with a global conservation effort at the same time. And that's what it looks like from a drone shot. This was only taken 2-3 weeks ago. So you can see how the branches, some of the trees are deciduous, but that's the layout. But notice it's just a small, relatively small area in the whole oak lawn. Those trees will grow up. It'll look like this again. And then hopefully we find a patch somewhere else. Oh yeah. I'm missing a slide there. Oh, okay. That's all right. I had another slide to show you, but we saved some time. So what else do we need to do? You can have a visionary plan that allows you to act, but actually it's the planning that's the valuable part. Once a plan's done, it's often out of date. What about principles? What about principles that you can bring into the way that you work, the way that you think, the way that you ask questions of one another? I like principles because they're universal. If the principles are right, you don't need a plan. So what are they? So the way that adaptation is defined by the IPCC is that you're adjusting to an actual climate or what you project to be a problem, and you're trying to moderate harm. But the one I want to really emphasise is exploiting beneficial opportunities. Think about the opportunities you can have for new plants, for more resilient landscape. There's more opportunity actually than there is risk. And what's resilience? So in engineering terms, resilience means the capacity to bounce back to be the same. Basically, you have a shock, you can come back and be the road, you're back to normal. Living systems, we can't really do that. They're not necessarily going to come back to normal. But it's about having the capacity for the botanic garden or your natural landscape to persist. It might be a little different, but it still persists. But it also continues to develop with ever-changing environment. So there's some plasticity, there's some ability to shape and move, and yet maintain all the values and benefits that you want. But there's a danger here. You have a heritage garden. We want to keep it exactly the same. No change, or keep all the same plants. You're actually not doing your job as a custodian if you do that, because you reduce its resilience, its capacity. The natural world, plants are adapting and changing all the time. You cannot expect the landscape to stay the same. You have to make some changes. As a custodian, and I'll get in trouble from the director for saying this, but as a custodian, your prime duty is to that landscape or natural area that you're looking after. It's actually not to your organisation. So if your organisation says, going to get rid of all those plants or we're going to keep the same, you need to say, hang on, I'm not sure that's quite resilient. We need to be more resilient. You might get in trouble, but that's my view. That's the position I take. I would argue against management if I felt the decision being made was going to damage the very thing that I'm being paid to protect. So I'm not asking to give your manager a hard time, but you need to be thinking in hundreds of years time scale, not just in a short time. So we need to learn how to change to sustain the landscape's benefits, functions and values. Individual species, the odd garden bed might change, but the overall landscape, our botanical collections will stay the same. But it's also about us changing individually. How flexible am I? It's not just about how, you could be saying the management need to change, but are you prepared to change? So these are some of the principles. I'm not going to talk through all of them because we don't have time, but I just want you to think about these, and I'll flick up a couple. Diversity and redundancy. So build your diversity. If you did nothing else in your landscape, increase the different types of plants you grow, there'll be some winners and losers, but you might have more winners if you have more species. It did nothing else, get the diversity up. The diversity also means the way you manage, the way you think, the people you employ, because different people bring different ideas and boost that resilience. Redundancy, talked about that in a managed landscape environment. It could be, and I'll use Montpellier as an example. You've got a well, you use a pump. Ask yourself the question, what happens to that pump fails? Do we have backup? No, you're not particularly resilient. Oh, we've got a backup pump. Oh, good. What if the power goes out? What if the city shuts down because of all the power being demanded to cool all these buildings, to build all these air conditioners? Do you have a generator? No. Well, maybe you need a generator. And not just think about a day, think about losing services for a week. Can you cope? If you can't support the collection for a week, if you lose services, maybe you need to change the collection a bit, or maybe you need to build more infrastructure. We all have to think like this now. We don't have a choice of staying the way we are because the world is changing. Connectivity is another one I'll talk about because I think that plays into collaboration and working together. In ecology, connectivity is about plants being able to spread their genetics, being able to move around, and animals too. I won't forget animals, maybe human beings. But connectivity can also be how we're connected to one another. How well connected are we? I know it's really hot, sorry. How well connected are we in sharing information, appreciating other people's views and perspectives? So connectedness also applies to people. So you start to get the picture. I'm talking about landscapes, but I'm also talking about people. It's plants and people. And we need to plan for succession of people as well as landscapes. Got a manual there, all this expertise in his brain. When he walks out the door, how much of that goes with him? How much of that do you have in the organisation? Have you documented it? The way he works, he might work in a particular way, it's really great. Have people learn how they work. Could be a horticultural or horticulturist or gardener on the team. Has a particular wonderful way of doing something. So you can document things, write them down. You can't document work attitude, work behaviour. So that culture of looking after landscape across decades, into generations, it's something we've got to get better at. We actually aren't doing a very good job of it at the moment, I have to say. Okay, skip past those. So I know we're running out of time. So what's the summary? Yes, it's confronting, but I want to leave a message of hope here because I think there is hope. We talked about lots of risks, but we need to understand what our capacity and what our knowledge gaps are on the site. And the only way you can understand your gaps is if you've done measurement and you've assessed your risk. You haven't done any baseline data, no measurement, you don't know how much water you use, you're already starting behind the ballpark. Acting now and developing a plan or planning to make risks, so you need to, you've still got time. You need to start now because every decision you make now becomes very important. And we also need to think about this. It's not just about our landscapes, it's our organisations, our systems and structures. Are they resilient and geared to a changing climate? Do we need to employ another person who could do a different role? Do we need to do things a bit differently? We need to think more broadly than just looking at plants. But I want to talk about the opportunities. So capacity and capability building is important. There's a lot of areas in the world that have very low numbers of botanic gardens, very low numbers of resources, and some of those are the most biodiverse, rich areas on the planet. So Montpellier might support another small garden somewhere, just a bit of advice. And I really want to emphasise the collaboration and sharing learning experience across, as I've said, cultures and contexts. So this is what the Climate Change Alliance is about. It's trying to bring all this collaboration together. Melbourne Gardens on its own would not have achieved anything that I've talked about if it wasn't very good at collaborating. So universities come in, people provide resources, we self-learned how to do things. So I'm a big believer in collaboration because I've seen how powerful that is in my own lifetime. Talked about succession planning, plants, but also people. We've got to think about the people who are looking after these landscapes, plants. And we've talked about, even if there wasn't any climate change and we become more adaptive, more continuous learning, our organisation will end up being better off anyway. I haven't seen any disadvantages to Melbourne doing this work. You've actually end up with a more diverse landscape, better skilled people, better systems. Even the database will actually improve because of all this work. And it should have improved years ago, but this acted as a nuisance. And that's pretty much the end, but I'm just leaving you with this. So I'm going to send around a French translation, and I'm happy to share this, but there's some links here that you can go and find this information for yourselves. You can also join as individual members. You can join the Alliance individually. You don't have to be an organisation. We're not exclusive. So if you're interested, feel free to look it up. But I really would like a lot more organisations to join. We're not putting a very hard Botanic Gardens line on the definition. Most of the focus is on Botanic Gardens, but some of the forums and learnings that go online would be beneficial to a lot of people, not just Botanic Gardens. And that's it, I'm done.
Very much. We've got questions.
Yes, thank you. That was very instructive. I do have a garden myself. I try to make it as sustainable as possible. But so like one question I'm always confronted with is like, how do you deal with uncertainty? Here in Europe, we hear that sometimes the North Atlantic current collapsed. So instead of warming, we could get a cooler and drier climate. Also, people from the IPCC say that in some areas of the world, they're just not able to predict the climate. They predict that it's going to warm up, but actually it's cooling. So you say you make your garden climate ready, but is that, and it's optimistic, and we need to be optimistic, but actually isn't that overly optimistic? Isn't that just like saying, okay, we can manage it, although if we were honest, we would have to say that we actually don't know what's going to happen. So it's difficult to.
So risk assessment about trying to manage that uncertainty, but there's no guarantees. But you know, if you use a similar analogy in the workplace, you have risk assessments for safety. So the analogy I like to use is house fire. I've not had a house fire ever in my life. Does that mean I don't take out insurance because it's never happened? Because the consequences of a fire for me would be devastating. So I think to me, we do need to act, but I take your point that can't always predict exactly. But I would argue that even if you increase the diversity of your plants in the landscape, that was the only thing you did, that would actually help cover some of that. But for many places in the world, there's some consistent projections. Most of the Mediterranean regions consistently, every time I look at the projections, they're drying and warming. Every southwest part of the continent where the Mediterranean zone is drying and warming. I think if you're in those areas, you have to assume that's going to happen. So in Melbourne, we take a precautionary approach. The data's not there. We assume a worse situation, try and work towards that. You may not. I think the other thing is if you're continuously adapting, you're more agile to shift back if things go the other way. So I think the message is about being adaptive and being self-learner, being prepared to continuously learn. Once we think we know everything, we're in a bad place. I think being prepared to learn and be adaptive means at least you can track. But there's a lot of uncertainty, I agree. I'm not trying to say this is definitely going to happen, but I think sitting there and doing nothing is actually worse. I don't know if that's answered your question.
Yes, okay, thank you very much. I was just thinking the botanical gardens, they're also a bit special in the way that we have had this period of big explorations, and then plants were introduced that came often from climates that were warmer, and you had to acclimatize them. And so I would expect that botanical gardens harbor a lot of species that are maybe not in the green zone, but would like to have a bit warmer climate. Actually, is there other good examples of this? But for example,
I can talk to that. So the research that's been done seems to indicate that species from hotter climates seem to tolerate cold better than cold species from cold climates heat. It seems to perversely go the other way. So Melbourne Gardens example, there's at least 500 taxa planted there that are quite old, that are tropical species. But we're not seeing it go so much the other way. So the other thing is, and I didn't try to get into too much theory, but in Botanic Gardens, we're growing plants in what's called the fundamental niche, or where plants can potentially grow when competition and other inhibiting things are taken away. In the natural world, plants are constrained by, they can't germinate, they can't move, so they're temperature envelope, the space in which they can grow in a natural environment might look quite small, but in cultivation they can actually go like that. That climate assessment tool that I showed you, that's why it uses multiple databases, because some of those databases show where plants are growing on their range. So we don't need to be so precautionary about those, because there's evidence to suggest that they're more plastic. One of the fears with tropical species, everyone thinks tropical plants, oh, they'll be all right because they grow in hot, but there's actually some suggestions already that they're actually at the ceiling. So in the tropical zones, those species actually might be more at risk because they're already growing the warmest temperatures known. There'll be species that will surprise us. We'll think that one's gone, but yeah, it's there 1,000 years later laughing at us. But that's going to be probably an exception rather than suggest. John.
You're very inspiring presentation.
Thank you.
Thank you. So you said increase diversity to manage risk, but at the same time, beware you could, by doing that, in fact, introduce invasive species. How can you solve that? Are there
There is.
invasive species? How do you know what they are invasive here?
Yeah, I didn't. Well, this is a bit of a challenging one, and I think I was challenged on this yesterday. At Melbourne, there is actually a weed risk assessment process. There's actually a formalised process where new introductions are actually assessed for invasiveness based on prior behaviour. The problem is we're assessing on behaviour that's been observed, not what they're going to do in the future climate. But we look for things like the capacity to produce lots of propagules, rhizomes, things like that. Australia has pretty strict protocols about plants anyway from invasiveness, so this is more about plants within Australia. That is a challenge, and that's why I put it up to attention. I actually don't have the right complete answer for you, but we can't ignore it. So I think it's being prepared to be very observant. We plant these species. We see any signs of really nasty behaviour, we've got to jump on it straight away. An example of that is our curator looks up the Southern Chinese collection, brought back this really rare Chinese plant. Next year it was jumping all over the place. She pulled it out and destroyed it, even though it's rare. She knew straight away that didn't want to keep this one. So I think it's, that's why monitoring is really important. A lot of gardens actually don't do very good monitoring already. I can tell you some really big name botanic gardens don't know how much water they use in the landscape. To me, that's an easy one. So baseline data, doing science, doing research becomes really important now.
Peter?
Yes.
We have one question online.
Yes. Read it for me.
Yeah. Natalie, you can speak if you want to ask your question. Yes. Okay. So the question directly. She's asking whether what you showed us had issues introducing it with two sort of issues, such as disease vectors like mosquitoes or these kind of things.
Yeah, I'm not that's more a question for a medical person, not a. It's the same sort of principle, I think, is that because we can't sort of project how certain diseases are going to behave, that's difficult. But I think this is where diversity does come important, because if you only have a landscape of certain species, and that's particularly prone to a particular disease, you lose that whole. You imagine that all the plane trees here are already getting affected. Could you imagine if a fungus disease arrived and love killing the plane trees and wiped out all the plane trees in Montpellier within a year? You'd have no assets left. So I'd be suggesting that you have a few different species so you don't lose a whole street. We've got to get away from monocultures, even in our urban areas. There's opportunities here where I think botanic gardens can trial rare or threatened species in their landscape and say to the local municipal government, we've got a new species we think can work, it's interesting, it's rare, it's valuable. We can actually help conserve it by planting it in the streets, but also provide shade and cooling. So I think there's a lot of very interesting prospects for botanic gardens to actually help society at the same time meet plant conservation needs. So do their duty, but also help. As I said, a lot of opportunities. So that's the way I'd be thinking about it. I don't know if that's answered the question.
The garden in Montpellier, we tried to focalize in Mediterranean plants, and we try to bring plants from, for example, from East Mediterranean.
Yeah.
So it's not so far that our climate, but even so, that it's the same region, but the climate is a bit different. So sometimes it's working and sometimes it's not working, because in East Mediterranean the weather is a bit warmer.
Yeah.
So some plants can't manage to grow in Montpellier's climate.
Yeah.
So it's very, very interesting, even by choosing vegetation which are almost very close. It's not working the way we wanted. And for example, if we want to bring plants from California, from maybe we try from Australian plants, we have to be careful not to bring pests.
Yeah.
But also some of them, we might find a very interesting Australian plants growing well in our garden, but there is many chances that the climate is slightly different and we don't manage. It's very interesting, all that trial, all that.
Well, I think that's your point. It's important to do the trials and do the experimentation. So I keep saying it's about acting now. We don't have to have everything solved this year. We don't have to have everything solved in 5 years, but we want to start have things sort of solved in 50 to 100 years. So it's not about panicking, but it's actually starting. And look, it might be trialing. You might identify an area of the world that works really well for your climate, and that's where you start to source from. But if you don't do the introductions, don't do the experimentation, don't do the work, you're not going to know. So I think it's continually being agile and adaptive. And even small, poor organisations can actually have a powerful effect if they're prepared to learn, prepared to collaborate. You can be a very wealthy organisation, stuck culture, and you think you know all the answers. You'll get to 100 years' time and everyone will have left you behind. I think the organisations that collaborate, one of the sayings I like to use is we often think about leadership as being, oh, I'm a fantastic person, I've got this big ego, I'm the best. But for me, leadership's different. So leadership for me is, see person John over there, he is a fantastic collaborator. To me, that is leadership. It's being prepared to work with others. I think botanic gardens are actually quite good at it, but they need to become better.
Question about the alliances or the collaborators you have. Does it sometimes include also nature reserves, or is it really different from what you're doing? You're interested in
it's similar. Sorry,
they're interested in conserving the species, high species richness, like you. But
it's a good question. Some botanic gardens actually have natural areas. So in Australia, I'm working with the Sydney Botanic Gardens on a climate change resilient strategy for them. They have massive natural areas that are part of their mandate. The challenge with those is we can't bring in plants, exotic plants, into those areas. And some of the species, some of the more threatened species have quite small ranges. If where that species grows, its provenance or where it naturally grows, has long north-south latitude, then you've got the opportunity to choose species from more normally. You still don't know whether those are actually going to work. It's still a bit unknown, but there is programs in Australia where we have what's called assisted migration. So we're bringing in species from a warmer climate and introducing it southwards. So we jump past that dispersal barrier. The problem is where you don't have that latitude, if your latitude's quite narrow, you don't have that choice. So this brings up a whole lot of ethical questions. Species X is not going to, looks like it won't survive. Do we let it die? And then the whole ecosystem might collapse because that species is actually a keystone for pollinators and a whole lot of things. Does that mean we need to bring in a species that is exotic to replace the function of that species? Well, these are the things that are being talked around about in scientific circles. Sounds uncomfortable. It's not my preference. But we may have to start, in a way, playing God, if you like, and actually deliberately bringing in species because we're going to lose a whole lot of other animals that rely on that plant that's gone. And these are philosophical and ethical questions. But if you have that latitude, you've probably got a bit of flexibility to do some migration. The other challenge in Australia is some species are very important to Indigenous people. They're totem species. And a lot of Australian plants, the actual temperature envelope is quite narrow because they haven't experienced the variability that some of the Northern Hemispheres have. And if you've got a totem species, which is important to people and you want to protect it, how do you do that? Because one conversation I know that was had with a particular group is Eucalyptus viminalis. It's a tree that likes water, probably under a future climate, it's not looking good for it. It's already struggling. And there is species that are to the north that probably could survive, but they look scrawny and don't look as good as this tree. And the conversation with this First Nations people is, well, how do we describe this? So the language was, we want to get strong men from the north to marry your daughters down south so that they continue to live. But when they show them pictures of those trees, they go, no way, we don't want those trees. So there's also cultural, what I'm trying to say, there's also cultural issues for species that are important to local people. And we're trying to work with them, but don't have the answers for it. So you can have the same thing with the community doesn't like the new trees that you're bringing in. But usually when you show people the species that you can grow, they get very excited. We have a growing friends group, which is a volunteer group in the gardens, and I presented this, and I was prepared because I actually found some species potentially suited and had them on the PowerPoint. And they're saying, oh, we're going to lose all these species that we love. I said, well, but you can have these ones. And they almost wanted to start straight away. So I think it's important. The lesson here is I think it's important that Botanic Gardens does show positive alternatives and opportunities and not dwell on the negatives. You might be losing this species, but there's a lot of things that we can do. If we are agile and adaptive, human beings, we're not very good at changing, but we have to become that way.
But the good thing, BGCI, the International Association of Botanic Gardens, they are mainly very large gardens, and inside those gardens they have like reserve areas.
Yeah.
And your alliance is making to work with all those gardens, and all the information is shared throughout the world.
Yeah.
That's the great idea of the GCI and the climate change.
And may well be that one partner or one member comes up with a better answer to that question than what I've given you. I'm not an ecologist. It is a real problem, that one, because we can't apply the same rules. Then again, if we don't do the work, don't do the research, how will we know? So we've got to start doing experimentation in that space.
You could easily you type GCI on the computer and you straight go to the Alliance of Climate Change in Botanic Gardens, and you will have the whole subjects and running and all over the world.
There's a program in New South Wales called Restore and Renew, and it's exactly that thing where they're looking. And it's an interesting one because they have parameters that you plug in to see where the climates of the future are. Once you plug in about 3 parameters, there's no matching climates. So that's what I talked about, it gets difficult. But the intention of that is they've also overlaid genetic provenance, so you're sourcing plants from the right genetic area, and they're actually starting to encourage people to actually move things that are genetically similar, but from a warmer, drier. So that's a government-based tool that's already happening in Australia, and there's probably equivalents in North America and elsewhere. But there's some ethical dilemmas with it.
Can I do an announcement?
Yes.
It's an opportunity. I'm John Devos. I'm the director of the Botanical Garden of Montpellier. And just wanted to say to the logical scientific community that the garden is open for research projects if you have some. We have some, as we discussed with Peter, some trees that are more than 400 years. So maybe this can be interesting for some project. No idea, but keep your word.
And if you want some ideas about potential research projects, I can share with you. I haven't even talked about it today, but I'm happy to share with Manuel or John some ideas that might work for you here. That may not be suited for you, but happy to share some. Even microclimate monitoring could be quite interesting to see what differences there are. So there's plenty of things that Botanic Gardens have done that might work for the university. I think one of the things about Botanic Gardens generally, people have known the plants for some time, know where they are, and they're often more secure, not necessarily perfectly secure, but they're more secure than outside places. So I know that university academics I work with just love that. And often they don't realise that it's there. So I'd encourage people to think about it as well.
Andrew.
Thank you. Okay. We're done.